Hello, and welcome back to another IBHL Math Speedrun with me, Bits. This is the third speedrun of today, and in this speedrun we're going to be cleaning up the last parts of chapter 1.4, which concerns the general binomial theorem. So, let's dive right in. So, first of all, we gotta ask ourselves, what is the general binomial expansion? We looked at what a binomial expansion is last time. It looks something like 1 plus, technically a plus x. It's just really a plus b to the power of n is equal to n choose 0, a to the n, plus n choose 1, a to the n minus 1, b to the 1, and so on. But we need to ask ourselves, what if this n over here isn't an integer? And that's where it gets a tad bit tricky. So, it is actually possible to still expand it. The question is you get 1 plus x to the negative 1. How do you expand this into a series? And the trick is you can actually approximate this and expand it into a series, and you can get a value for this, which is quite important. And this is discovered by Isaac Newton, for those who don't know, and I'll be showing it to you right now. So, the general expansion for 1 minus x to the power of negative n. So note that, first of all, this has to be a 1. So in these questions, we're going to have to convert, say, like the binomial is 2 minus x to the negative n. Well, we're going to have to rewrite this as 2 times 1 minus x over 2 to the negative n instead, and then bring this 2 outside of the brackets if we know what the exponent is, because we can only expand it if this first digit is 1. And so this will be equal to 1 plus n to the x plus n times n plus 1 over 2 to the x squared plus n times n plus 1 times n plus 2 divided by, this is 2 factorial really, this is 3 factorial, x cubed, and so on. And so that's how we can expand this binomial. So I guess the other thing to note, actually, this is a bit weird that the textbook teaches it in this form. The normal form I know is just 1 plus x to the n is equal to 1 plus nx plus n, plus n times n minus 1 divided by 2 plus n times n minus 1, plus n times n minus 1 plus n minus 2 divided by 3 factorial to the x cubed. This is the one I usually know. And yeah, the only other condition is that negative 1 has to be less than or equal to x, less than x, which has to be less than 1, so the series converges. And so that's the only other condition. So that sounds a bit complicated, so let's look into some problems and see what we can do. So, okay, let's do our first problem. Expand the following up to the term in x cubed, given that the absolute value of x is less than 1/2. And the equation they want us to expand is 1 over 1 plus x. Okay. So we know 1 over 1 plus x is equal to 1 plus x to the negative 1, so we simply have to expand 1 plus x to the negative 1. And from the binomial expansion, we know that's going to be 1 plus nx, where n is negative 1, so it would be 1 minus x, plus n times n minus 1 over 2 factorial times x squared. So that's negative 1 times negative 2 divided by 2. So that would be x squared, simply, just x squared. And then this would be plus negative 1 times negative 2 times negative 3 divided by 3 factorial, which is negative 1, times x cubed. So it would be 1 minus x plus x squared minus x cubed. And that should leave us with the correct answer. And yeah, this is the correct answer. So this, of course, is an infinite series, but if you were to expand 1 plus x then minus 1, you would get an equation like this. So let's move on to the next one. Next one we're going to try and tackle is 2 over 1 minus x to the 3. And, well, we know this is equal to 2 times 1 minus x to the negative 3. So we can simply expand 2 times 1 minus x to the negative 3. So what do we have here? That's equal to 2 times 1 minus, so it's plus 3x. I'll write this out in full so you guys can understand. So this would be 1 plus negative 3 times negative x plus negative 3 times negative 4 divided by 2 times negative x squared plus negative 3 times negative 4 times negative 5 over 3 factorial times negative x cubed. So times negative x cubed. So let's expand all this inside the brackets. So it's still going to be 2 multiplied to everything. 1 plus negative 3 times negative x is 3x plus, and then negative 3 times negative 4 is 12. 12 divided by 2 is 6. So this would be 6x squared plus, and this would be negative 3 times negative 4 times negative 5 over 6, which would be, I believe it's negative 10. Is it negative 10? Yeah. Negative 10 minus x cubed. So that would be 10x cubed. And remember, we have to multiply all of this by 2. So the real sequence would be 2 plus 6x plus 12x squared plus 20x cubed. Let's just check we've got that correct. And yeah, we've got that correct. Okay, that's cool. So now let's move on to a trickier problem. So we have, third problem is show that, let me just put this here. Show that square root of 1 minus x times 1 plus x, over 1 plus x is equal to 1 minus x plus x squared over 2 minus x cubed over 2, where x, the absolute value of x is less than 1. Okay. So where would we start with this? What I would do is I would start with, this would be equal to 1 minus x to the 1/2 times 1 plus x to the negative 1/2. Alright? And so we can expand this, and we can Actually, we can see what we can do for the left-hand side, but first let's expand the right-hand side. So 1 plus x to the negative 1/2 is equal to 1 minus 1/2 x plus actually yeah, okay. 1 minus 1/2 x plus so this would be negative 1/2 times negative 3 over 2 divided by 2. So this would be 3 over 8 x squared plus 3 over 8 x squared minus, and this would be negative 1/2 times negative 3 over 2 times negative 5 over 2. So that's 50 all over 3 factorial. So this would be 3 times 2. So this would be negative 5 over 16. So minus 5 over 16 x cubed. And what I think we have to do is we have to expand this on this side and then multiply it out. So we have 1 minus 1/2 x, and then the next term would be 1/2 times negative 1/2 over 2 factorial times negative x squared, which is equal to negative 1/8 x squared. So minus 1/8 of an x squared, and then the next term would be negative 1/2 times negative 1/2 times negative 3 over 2 divided by 3 factorial times negative x cubed. So this would be equal to negative 1 over 16, I believe, x cubed. And so now our job is to multiply this out, but we're saved because we only have to multiply it out to the cubed term. So the first term is obviously going to be 1 times 1. Now let's get all of the terms of x. So we have 1 times negative 1/2 x, 1 times negative 1/2 x. It looks like negative x. Is that correct? Yeah, minus x. And then we have the x squared term. So we have first 1 times 3 over 8x, 1 times negative 1 over 8x squared. Sorry, 1 times 3 over 8x squared. So we have to multiply 1 times 3 over 8x squared, negative 1 times negative 1 over 8x squared, and negative 1/2 times negative 1/2 x. So that's going to be 3. Let's just add up the coefficients. 3, not in red. 3 over 8 minus 1 over 8 plus 1/4. So this is looking like 1/2 x squared. Oh, I just erased it. Okay. Plus 1/2 x squared. And finally, we need to calculate the x cubed term. So that's going to be negative 5 over 16 minus 1 over 16 plus 3 over 8 times negative 1 over 8, which is negative, negative 3 over 64, I think is what I got. Yeah? So this should be, is that correct? Oh, no, sorry, that's not correct. What am I doing? It should be negative 5 over 16 minus 1 over 16. So let me just draw which ones we have to multiply. If I zoom out a little. So we need to multiply 1 by negative 5 over 16, 1 by negative 1 over 16, 1 half with 3 over 8, and negative 1 half with negative 1 over 8. So that would be negative 5 over 16 minus 1 over 16. Negative 1 half times 3 over 8 is negative 3 over 16. And negative 1 half times negative 1/8 is 1 over 16. Is that correct? Yeah. So we have, what is this? We can immediately cancel these two out, and so we're left with negative 8 over 16, which is equal to negative 1 half x cubed. So minus 1 half x cubed. And I think that's what we needed to prove it equals. Yep. So as you can see, these two are the same. And so we've successfully proved that this expanded is equal to this. Just remember that this is when the absolute value of x is less than 1, because the series only converges for values of x less than 1. So let's move on to the next one.
Hey guys, I'm back. Sorry about that. So let's move on to the next question. So the next question is we need to find the first 4 terms of the binomial expansion of 2 minus 3x to the negative 3. Oh, that didn't work out. 2 minus 3x to the negative 3. Where, of course, I can't press a line. X is less than 2/3. Absolute value of x is less than 2/3. Okay. So, as I said earlier, we're going to have to convert this into something of 1 plus a to the negative 3. And so, how we're going to do that is we're going to divide everything by 2. So we have 2 times 1 minus 3 over 2x, all to the power of negative 3. And then we need to bring the 2 outside the brackets. And how do we do that? Well, this is simply 2 to the negative 3 times 1 minus 3 over 2 to the negative 3. This is x. And so we actually have 1 over 8 times 1 minus 3 over 2x to the negative 3. So now we have to expand this part. And let's just quickly expand it. So that would be, what is this? 1/8 times 1 minus 3 over 2 times minus 3 plus 9 over 4. 9 over 2x. And then this would be minus 3 times minus 4 divided by 2 factorial times minus 3 over 2x squared, which is equal to plus 6 times 3, 8, 6 times 9, 54 over 4, which is 27 over 2, x squared. And then we have, of course, plus, and is it first 3? First 4 terms. First 4 terms. Okay. Plus, and this is negative 3 times negative 4 times negative 5 over 3 factorial times negative 3 over 2x cubed. So that would be equal to, this is equal to negative 10 times negative 27 over 8. That is negative 5 times 27 over 4. Well, what's 5 times 27? Well, we have 135 over 4 x cubed. And so now we need to multiply everything inside these brackets by 1/8. So this should be simply 1/8 plus 9 over 16x plus 27 over 16 x squared plus 135 over 32. Oh, 32x cubed. And let's just check if we're right. Yeah, we're right. So just remember that's a 9. This is a 9, and this should be the final answer. Okay. Now, moving on to the final question of this speedrun, we have that 7, and then A, find the first 3 terms of the binomial expansion of 1 divided by square root. I'll just write this out. So this would be 1 divided by square root 1 minus 2x, where of course the absolute value of x is less than 1/2. So this we know is equal to 1 minus 2x to the negative 1/2. And what we have to do is we have to make this term, oh actually no, it's already in the form where we can solve it. Okay, that's pretty interesting. So this should be pretty easy. This should be 1 plus x, because remember minus 2 times minus 1/2, and then plus, and then this is not minus 1/2 times minus 3 over 2 times 2 factorial, over 2 factorial times minus 2x squared, which is equal to 8 over, let's say 3 over 8 times 4, which is 3 over 2 x squared. So that was, okay, this is pretty easy. But there is a second part to the question. So what is that second part? That second part is we need to hence obtain the expansion, oh no, of, and let me just write this out because this is not nice. So they're looking for the expansion of 2 plus 3x cubed over the square root of 1 minus 2x up to the term x cubed. Okay, this isn't looking nice because first we need to expand this, except that we can actually use the binomial expansion to help us expand this. So that would be equal to 2 to the power of 3 plus 2 to the power of 2, 3x to the power of 1 times 3 choose 1, which is 3. I'll just leave it as 3 choose 1. Plus, plus 2 to the power 2 times 3x squared times 3 choose 2. And finally, we need to add 3x cubed. So what all of that is equal to is it's equal to 8 plus 4 times 3 is 12 times 3, 36x, plus 2 times 3x squared times 3 choose 2 is also 3. So that would be 2 times 9, 18 times 3 is 54. 54x squared plus 27x cubed. And so we have to multiply all of that by this equation over here. Where's it gone? Oh, there. 1 plus x plus 3 over 2x. So 1 plus x plus 3 over 2x. And so this is going to be quite a long one. Hopefully we won't make any mistakes. So 8 times 1 is 8. 8 times x is 8x. 8 times 3 over 2x is, oh, did I say up to an x cubed term? Huh. Okay. Because we should have the x cubed term here anyway, so I'm going to quickly add it. that would be -1/2 times -3/2 times -5/2 divided by 3 factorial times -2x cubed. This is equal to -5. Sorry, that would be equal to 5 over 3, 1, 2, 3, 4, 1, 2, 3, 5 over 2x cubed. So that would be plus 5 over 2x cubed. Okay. Anyways, back to this. 8 plus 8x plus 8 times 3 over 2 is I'm having a 12x squared plus, and then we need to just multiply 8 by this term over here, 5 over 2x, and that would be 20x cubed plus 36x times 1, 36x plus 36x squared plus 36x times 3 over 2x, 3 over 2x squared, I should say, is 36 over 2, 18, 18 times 3, 54, x cubed, plus 54x squared, plus 54x cubed, plus 27x cubed. So this is quite a long one. So at the very end we have, let's just bring this up, 8 plus 8 plus 36 is 44x, plus 12 plus 36 plus 54 is 134. Oh wait, 54 isn't divisible by 12. What am I doing? 12 plus 36 plus 54, 102x squared. And hopefully we don't get this wrong because this is quite long. Plus 20x plus 54, 54, 27. So 20 plus 54 plus 54 plus 27 is 155x cubed. So we should get that is the final answer, 8 plus 44x plus 102. Where is it? Oh wow, we actually got it correct. I was expecting a problem. But, so that is how you expand this complicated equation. So that was a lot of things to go through today, and I hope you've learned about a lot about the general binomial expansion. I hope that you can now expand binomials. They're quite tricky though, so I would highly encourage you to go through the rest of the problems yourself if you're not getting it. And otherwise, the next thing I'll speedrun today is the chapter review, and that will be it for chapter 1. See you next time.